Hi, everyone. Thank you so much for joining us for our next session of our Python and AI Level Up series on agents. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter and moderator to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Pamela, thank you so much for joining.
Hello, everyone. Welcome to our Python AI series, where we are learning all the fundamentals of building with generative AI in Python. So we've already had 7 sessions in this series. If you missed any of those sessions, they were all recorded, and we have a page that lists all of the recordings and the slides and the code samples so that you can catch up at any time. Those should be available forever, as long as the internet lasts. Now, today we are talking about agents, and then tomorrow we're talking about MCP. So those are our final 2 topics in the series. They're both pretty exciting topics. They're new topics, really in the last year. So we're pumped to be talking about them for our final part of the series. So now let's talk about agents. If you do want to download the slides, you can see they're available from this URL. You can follow along with the slides. You can share the slides. You can give this talk yourselves to your own communities, whatever you want to do with them. We're going to be talking about a few different AI agent frameworks today. We are going to be focusing on Microsoft Agent Framework, but we're also going to be showing some Langchain. Those are some of the 2 biggest frameworks we want to talk about. And really, but using them as examples of how generally to build agents, right? So even if you're using a different framework, today's topic should be helpful for you. So we'll look at different agent architectures, multiple tools, multiple sub-agents, workflows, that sort of thing, how we can add humans in the loop, how we can do planning, memory. We're going to try and touch a little bit on all these topics. Now, we only have an hour, so we can't go super deep into these topics. Like, really, we need a whole series just about agents. But we want to give you an overall understanding of the space for when you're building agents. If you do want to follow along with the code samples today, this is the repo we're using. This is a new repo that we haven't used before in the series. So what you can do is we'll put this link in the chat, and then you can click through on it. So I'll go ahead and show. So I'm going to click through, and that'll go over to the GitHub here. So here's the actual GitHub repo. And on that GitHub repo, you're going to click on the code button here, and you'll see 2 options, local or code spaces. You can set it up locally if you want. If you do set up locally, you do need to read the README to see how to configure your environment variables. What's easier is to set up in code spaces where everything is set up for you and you don't have to configure anything about the environment. So what this does is opens up a code space. A code space is a VS Code inside your browser that has all of the code from this project set up and has Python installed. It has the packages installed, so that once everything loads, we should just be able to run the examples from the repo. So you can give that a few minutes to set up, and then I'll continue talking while it sets up. So first of all, we have to define agent. And this has actually been very, very hard to define over the last year. For the last year, we've all known that agents were a big thing, but we've had a hard time to saying exactly what an agent was. And we've had a few definitions over the last year, but I'm happy to report that we now have an official definition, thanks to our good friend in the Python community, Simon Willison, who has been collecting agent definitions over the past few years. And this is the current definition that we're going with. An LLM agent runs tools in a loop to achieve a goal. And I like this definition because what you'll see is that in the Python agent frameworks, this is pretty much how the Python agent frameworks think of agents as well, is that we'll construct an agent, we'll give it a goal, and we'll give it tools. And that is the essential agent that we're going to see over and over throughout all of our Python examples. So this is the definition we're going with today, is that an agent runs tools in a loop to achieve some goal. Some of these tools might be research tools. Some of them tools might actually take action and change things about the system. Some of the tools could like sense things in an environment. The tools could be all kinds of things. But the thing is that we're giving the agent the ability to decide what tools it's going to call, figure out the most appropriate tools, figure out, what parameters it's going to call those tools with, and then, keep on iterating until it's used all the tools that it thinks is necessary and has reached the goal. Now, there's often additional features associated with agents like memory and planning and human in the loop and stuff like that. So we'll look at that as well. But I'll consider those to be, bonus features. So how do we build an agent using Python? Here are some of the top agent frameworks that we can take a look at, right? So the one we are focusing on today is Agent Framework. This is a framework from Microsoft. It is really new. It just came out in the last month. And it is basically the successor to AutoGen and Semantic Kernel. So if any of you used AutoGen or Semantic Kernel in the past, basically Microsoft took like everything that people liked about those two frameworks and combine them into a single framework that has everything and also just has really good support for, Azure AI models as well as other models too. So it's a framework that really has support for quite a few things. It's a really solid framework. And I've found it to be pretty easy to use just over the past month because, it hasn't existed for very long, but I've been able to do a lot with it in its short existence. We are also going to look a bit at Langchain. Langchain V1 actually just dropped today officially. It's been in alpha for the last few months, and today is a day that it's officially not alpha anymore. So Langchain V1 is Langchain's new. So we've had Langchain around for quite a while. It was basically the first agent framework. It came out years ago, and it's gone through a lot of iterations. They've had multiple versions of it, but they have had so many users of it that they really learned what people wanted from a framework and what they needed to make a framework that would that people would be able to use for the most number of scenarios and that would be simple to use for the most number of scenarios. So that's what Langchain V1 is. It's the new version of Langchain that it's agent centric from the start, and it's designed to make it easy to do what most people want to do with agents. There's also Pydantic AI. That's from the Pydantic team. That's specifically designed to work well if you care about type safety and also, using like open telemetry, observability, and standards. They're big into adhering everything to open standards. And then there's OpenAI agents, which comes from OpenAI. So those are some of the Python AI frameworks. There are so many, so I can't fit them all in this slide, in the repo, and today. But these ones are all good ones to know about. And if you check the repo, you will find examples from all of these frameworks in the repo. So if you're interested in something, you can, browse through the repo to see how you can use that framework. So first, we're going to look at the simplest agent architecture would be an agent with a single tool. So how this is going to work is that we have an LLM. The LLM receives a request from the user. The LLM calls the tool, get back a response, and then based off that tool response and the original user's request says, oh, okay, I know how to answer your question. Here's the response, right? So for example, if the user says, how's the weather in SF? And the LLM has this tool get weather, and that tool accepts, the city name as the argument, the LLM is going to say, okay, I should call get weather with San Francisco as the city name. And then, it gets back some information. And then it gives a nice, user-friendly response to the user, right? So let's actually try that out, right? So going back over to our code space here, and I'm going to open up the examples folder and go to agent framework _ tool. And I'll make that bigger. And let's see, what else can I do to make it more visible, bigger? Okay. All right, so here we've got the code for it. So at the top, we have a bunch of imports from the agent framework. Then, we set up some logging. Then we configure the OpenAI client. So all of the examples have the ability to connect to Azure, OpenAI, to GitHub models. That's what we're using in the code spaces because it's free. So it should just work. To Olama, if you wanted to use local models, they would have to have really good tool calling support. So many of them will not work actually because tool calling is hard for local models. Or just to openai.com, right? So we configure our connection to a LLM provider. Then we define our tools. So in this case, we're only going to have a single tool, which is get weather. So this get weather function takes in a city, and that is a string argument. And we also give a description of the argument. So we say, okay, this string is the city name spelled out fully, right? So generally, when you define functions that are used by an agent framework, you want to give as much information about the arguments of that function as possible, because all of this is actually going to get sent to the LLM. So the LLM is going to say, oh, okay, get whether there's a function, it has a city parameter, and that city parameter has this description, and here is the description of the function. So all of this gets sent to the LLM. So you want to put as much information as possible in your function signature. Then we have just a jank implementation here. In reality, we would hook this up to an API to get back the actual weather for San Francisco. And then we construct the agent here. So let me just put this on a few lines so we can see it. So we create the agent and we pass in our client that's connecting to the model provider. We give it the overall instructions. This is the system prompt. And then we give it a list of tools. So in this case, we're only giving it a single tool. So now that that's all set up, we can finally run the agent with the user's question. So we're just going to say, okay, how is the weather today in SF? So we run that. And we're going to watch to see what it decides to do. Is it going to call our function? So yes. So what we can see is there's a logging statement here that says getting weather for San Francisco. So it called that function with the string San Francisco, right? So that the LLM decided to turn this lowercase SF into this expanded string San Francisco. So that's the kind of thing that LLMs do when we give them tools, is they decide on the arguments so they can do some cleaning up along the way. Now, when they're doing that cleaning up, they're making a lot of assumptions, right? They assume that SF means SF California, right? Which works in my case. That is what I meant. But depending on the context of the user and where they are, maybe there's SFs in Europe or other places. I know there is actually San Francisco's in like Mexico, right? So we said if we asked it, like really, you should have a get weather function that takes more than just city, right? It should take, latitude, longitude, country, all that. So you do want to think carefully about, what arguments your tools expect and, whether your agents can accurately call that with the right arguments. But in this case, it did a good job based off the tools we gave here. So what's happening behind the scenes is that when this call goes out, the agent framework is turning this function signature into JSON schema. So for those of you who joined us yesterday for tool calling, what we saw is that in tool calling, we have to give a JSON schema of the function. So you can imagine that behind the scenes, the agent framework is taking this function signature and inspecting it, and then rewriting it into a JSON schema, and that's what gets sent to the LLM. All right, so there we had the single tool example. That's just to show us, how this works. Now, what we're usually going to use is multiple tools. That's much more interesting because there the LLM has to, pick from the tools, whether it's going to use any tools at all, which of those tools going to use it, and what order to call the tools in, right? Because sometimes the order does actually matter because maybe one tool has information that the other tools needs. So imagine we have, this one here. The LLM has get weather, get activities, and get current date, right? If get weather and get activities both need to know the current date, then we have to call get current date first to find out the date that we're going to pass into those functions. So let's see what the agent decides to do. So we'll open up agent framework _tools.py. And here we've got our imports as usual. And now we've got the get weather function. We have get activities. So get activities, this one is taking city and date. And you can see that with the date, we also specify what format we want it in, right? So get activities needs to know both city and date. And then get current date doesn't take any arguments. It just returns back the date. So then we say, okay, you help users plan their weekends and choose the best activities for the weather, include date of the weekend in the response. And we give it get weather, get activities, get current date. Now, it doesn't matter what order we give the list in here, because the LLM's just going to decide, based off the user's question, what order it's going to call those tools in. So then I say like, okay, what can I do this weekend in San Francisco? Let me change that to SF. So it's going to go and look at that query, look at its tools. And what you can see is that it immediately called get current date. It realized it needed to know that before it could really do anything else. So it got the current date, then it got the weather, then it got the activities, and it called get activities twice because a weekend is 2 days. And it realized it had to check for both October 25th, which is correct. Let me just double check today's date is October 22nd. Yeah, October 25th and 26th. So it looked at today's date. It realized that the weekend is the 25th and 26th, right? So it did that calculation correctly. So it called get activities twice, one for Saturday and one for Sunday. So that's perfect, right? It did everything in the right order in order to be able to get the right information to answer this question. And then we get back the final response and to actually answer the question here. It says, since it's going to be rainy, then you should visit a museum. All right, so that's working well. I do see a question about why we're using async def. So these are async functions that are also called coroutine in Python. And you're going to see it quite a bit when using agent frameworks. A lot of agent frameworks are what we call async first or even async only. And that's because it's generally going to get you much better performance if you use async when you're calling LLMs. I have a blog post about that we can link to so that you can read more about it. There we go. Why your LLM-powered app needs concurrency. So you can read more about it in that blog post. But for agent framework, it is it's I would say it's like an async only, async first framework. So we're generally going to be using a lot of coroutines when we are using agent framework. But that's a good thing to take a look. Like some frameworks will support both async variants and non-async variants, and some frameworks will just always assume you're going to use async. All right. So now let's look at a more advanced architecture. This is what we call you could call this the supervisor architecture. So in this one, you have a supervisor agent, and it decides which specialist agents should handle a task. So this is a good one if you have a more general agent that people are using just for lots of different things. Like basically like ChatGPT is like a supervisor, right? Like it has all these different, there's lots of different things you can do with ChatGPT, and it can just delegate to, to a sub agent, right? So what we're going to do is figure okay, here's a supervisor agent. Here's this generic task coming in. Let's delegate to a more specialized agent, right? So in this case, we have a supervisor agent, which can delegate to a weekend planning agent or a meal planning agent. And that the weekend planning agent has tools to search activities and check weather, just like the ones we've been doing. The meal planning agent has very different tools for check fridge and search recipes, right? Now, you could just make a single agent that has those 4 tools, right? And that could work. But generally, one of the issues you'll see when you're designing like agent application is that if you throw too many tools at an LLM, it can have a hard time deciding which ones to use. So sometimes people will use this architecture of basically like making sub agents. And so that, the LM just has to decide, okay, is this a weekend planning task or is it a meal planning task, right? And if it can figure that out, then it doesn't have to worry about the exact tools. So this works well if like the tasks are distinct enough. It's not going to work if there's like a lot of overlap between the tasks and you like, need to mix and match the tools. But if there's very distinct tasks, then you can use this sort of architecture. So let's take a look at how we actually implement this in Agent Framework. So we're going to go to Agent Framework Supervisor.py. And so for this one, let me scroll down to the bottom here to show how we implemented this. Okay, so here's a supervisor agent. It says you're a supervisor managing 2 specialist agents, weekend planning agent and meal planning agent. Break down the user's request, decide which specialist to call, maybe both, and then synthesize the final answer. And then we just give it the agents as tools. So this is a common way to implement this, is to actually just wrap sub agents as tools. And, because LLM are, we already have handling for tools, right? And so then what you can see is this plan meal tool takes in a query, and then it just calls an agent and gives back the response from the agent, right? And so then we have the actual meal agent, and that's got its own tools, find recipes and check fridge. There's their tools. And then we have the other tool that calls the weekend agent and returns a response from the weekend agent. And, here's the definition of the weekend agent, which has the 3 tools that we've seen before. So that's how we're going to implement Supervisor, is by wrapping those agents up as tools. And this might seem kind of like weird at first, like, oh, why do we have to wrap them up as tools? But it turns out like it's just helpful to think of everything in terms of tools. If you can, when you're coming up with your architecture, if you just think of it that way, because that's the way the LLM is going to think of it, right? LLMs only really know about tools. So if we can, figure out how to map our architectures to tools, then, then we can make anything happen. So here we can say, I said my kids want pasta for dinner. So it said, okay, we're going to use the plan meal tool, which calls in the meal planning agent. And that looked for recipes, and that checked the fridge. And then we got back the responses, right? Now we could change to something else, like, what the heck do I do with kids this weekend in SF? This is also my like parenting helper agent here, which is like, these are the 2 main things that I need to do. All right, so this time we got the plan weekend tool invoked. So that sub agent, and that one got the date, it got the weather, it got the activities, and we get the suggestion back from the agent here. So I see a question like, does the supervisor agent consult an LLM in the background? So the supervisor agent is an LLM, right? So if we look at it here, we can see that it actually is an LLM, right? So it is, it's got its system prompt here, and it's making a call to the LLM with this system prompt and these 2 tools. And that LLM is suggesting like, oh, call this or call this, right? And we could even try it. Let's just try it. Let's go hard, right? And what should I make for dinner tonight? All right, let's see, right? So if we give it, we're just we're really keen on getting some help here, getting all of our questions answered at once, right? So it decided to invoke both the tools. And I think it actually decided to do it in parallel because it's invoking both the tools. And and so we got back all the responses, weekend activities and dinner suggestions, right? So this can work really well for, for when you have these distinct tasks, which can be thought of as sub agents. And then you can like really, and this allows you to get a lot fancier with the tools and the sub agents and not worry that you're distracting the main LLM, right? Like this really helps with keeping the main LLM focused on distinguishing between the overall tasks. and giving you the flexibility to add all kinds of tools to these LLMs and not worry about distracting the main one. All right. So there's a super. I see there's a lot of questions following up on this one, right? So questions like, oh, can we pass a document defining all the agents? I mean, ultimately, you know, it's just whatever you're putting in the LLM call. So you can have a much longer system prompt, right? So I do know some people that will actually describe for each of the agents what tools they have, and so they'll actually list all the tools from each agent. And so you can take that approach if you find it's helpful, right? It's all about what are you gonna put in your system prompt, and what are you gonna put in your tool description, right? Because you can see, remember, also this is gonna get sent to the LLM, right? So you can also do a much longer function description, and this will get sent to the LLM. So what's going to get sent to the LLM is the system prompt and the function signatures. And so you have to decide what you're going to put into that to really help it make a decision. And you can start simple and then evaluate and see where it's getting confused, and figure out where you need to add more specificity in order to get a better response. All right, now I see a question about Langchain. All right, so this is a good point to bring in the other frameworks, right? So these were all with Langchain. Okay, so these were all with Agent Framework. Yeah, so let me open up like the tools one, right? This is like our classic chat an agent with multiple tools. So this is with Agent Framework. So what I'm going to do is open up the side by side with Langchain, because what I want to show you that is that it's really building agents across these frameworks is very similar. So this is a side by side. So what you can see is that in Langchain v1, I call create agent. I pass in, my model, which is like my client, right? These are equivalent. I pass in my system prompt, which is same as instructions. And then I pass in my tools, which is exactly the same as this one, right? Same list. And then we can look at the, tool definitions, right? So the only difference here is that in Langchain, there is an @tool decorator, which helps Langchain know what which functions are tools in your program. Everything else is the same there, right? So what you can see is that the Langchain code and the Agent Framework code look really similar. Now, let me also just go ahead and bring up Pydantic. Let's see, I've got Pydantic here too, right? So what happens if we look at, all right, so we've got that one, we've got that one. Okay. And now here's Pydantic. Let me really try and line them up here. Okay. So Pydantic, we pass in the model, we pass in the system prompt, and you pass in the tools. Do you see how close these look to each other, right? There are some differences, but all of these agent frameworks have the same idea of what an agent is, right? An agent is connecting to a model from a model provider. It has a system prompt and it has tools, and then it's going to call those until it gets a final output, right? Here's where we call them and we get back the final output. So all of the examples that I showed, you can build those same examples in your favorite framework, and you're going to see the code is really similar. So at least for all the examples I've shown so far, the code is nearly the same across the frameworks, which I think is great, because you can you learn one framework and then you can apply your learnings to the other frameworks, and it becomes easier to think between them. Because, increasingly at companies, you might actually have different projects that use different frameworks, and it's helpful to be able to understand the multiples. And now I get the question, of course, which framework should you use versus other frameworks? I want to be equal opportunity here. I do actually think they're all great frameworks. I would say Microsoft. Okay, so Agent Framework comes from Microsoft. So if you are like a Microsoft heavy shop and you're already using lots of Azure things, you're using Azure AI, you're using Azure AI Foundry, you're using the agent service, I think it makes a lot of sense to use Agent Framework, because it's going to have support for the Azure stuff, sooner than most other frameworks, right? Because, it's from Microsoft, like we're in the know, like it's really easy for us to get features in for Azure stuff. So if you're a heavy Microsoft shop, definitely makes sense to use Agent Framework. Even if you're not, it's a solid framework. But I'm saying if you are a Microsoft heavy shop, I would definitely consider Agent Framework to be your a pretty top choice there. Langchain. What's great about Langchain? Huge ecosystem. Many people using it. They just got a a bunch of funding yesterday. So they also have a large engineering team behind it that's adding more features. They have a observability platform that's quite nice called Langsmith. I have it actually up over here. We'll see it later. So they've got some great observability there. So good ecosystem, big team, and Langchain v1 is a nice solid API, right? To be honest, I didn't like the previous versions of Langchain, but I do like the new version. Solid agent framework, and you've got a big community ecosystem there. And then Pydantic AI, why would you use that one? That's coming from the Pydantic team. If you're already using a lot of Pydantic, or if you're already using Logfire, and if you particularly really want type safety, open standards like open telemetry, then Pydantic AI can be a really good fit there. So that's one way of comparing them. Hopefully that gives you some idea of how to decide, but honestly I think they're all good picks, and you could start with any of them and have a good experience with it. I guess I'll warn, like, agent framework is pretty new, so you may need to file some issues if you're looking for examples that you can't see yet, right? The team is very rapidly building more examples out for it. Langchain v1 itself is quite new. So Langchain is out there and has been there for a long time, but you may get a little confused when you're looking for examples of how to use Langchain v1, because that's the new version. So for Langchain v1, go to their documentation first. Don't search the web. Go to the docs first. The new docs are quite good. You're going to have to start from the docs, because if you search the web, you're going to find outdated stuff. With Pydantic AI, you can search the web because they haven't had such big changes across them. All right. So, okay, good. Hopefully that helps. Now we're going to start to see ways in which things do start to diverge a bit across the agent frameworks when we get into more sophisticated or complex architectures. So let's talk about workflows. Many of us are actually building not just agents, but agentic workflows, right? And I'm going to define, this is my definition, but an agentic workflow is some sort of, program, some flow that involves an agent at some point. And that agent is usually doing either some research or decision making or answer synthesis, right? So it's something like in the past we might have used like some like jank regular expressions, but now we have an LLM that can make a better decision for us, right? So when you add, when you make agentic workflows, then you can have much more powerful workflows because you have the capability of an LLM. But it does also mean that your workflows are non-deterministic, right? Because you have an LLM, and LLMs are difficult to predict. They are non-deterministic, right? So remember, every time you add an agentic call, anytime you add any sort of call to an LLM into a program, you are increasing the non-determinism of a system. You're increasing the risk of a system, the possibility of failure. And so you need to do it really carefully and make sure that this is definitely a place where you want to call an LLM, because you're getting more, more benefit than drawback. So how do we build workflows in agent frameworks? Because it's such a common thing for people to build workflows, like for, like background tasks, processing, there is built-in support for many frameworks. So in agent framework, they call it workflows. So it's quite easy to find if you search for workflow. And they use a class called workflow builder. And there's also special builders for common types of workflows. And there is a visualization tool that you can use to visualize your workflow called DevUI, which we'll see today. In Langchain v1, you would actually use LangGraph. So Langchain v1 is built on top of LangGraph, which is a package they've had for a while for doing these graph-based flows. So if you wanted to build a workflow, you would potentially want to go straight to LangGraph and make a graph in LangGraph. So I will show an example using LangGraph later today. And then Pydantic AI also has a graph, and they call it Pydantic graph, right? And you could visualize that with some diagrams. So interesting, all the frameworks do like to support the idea of graphs or workflows, and they also often have special ways of visualizing those and making them easier to understand and debug. So let's look at how we do it in agent framework, right? So we're going to do this workflow here, and this workflow actually uses a lot of LLMs. it's a very, language heavy workflow. So we start off with a writer, which is going to write a first draft of something. Then we have a reviewer, which is going to review it and say how good it is. And if it is good enough, it'll go to the publisher, which will just format it. And if it's not good enough, then it'll go to an editor. So this is what we'd be calling a conditional branch, right? I mean, you just think about it as code, it's just like an if statement, right? So if the reviewer says that that the quality is not high enough, it'll send it to the editor, and the editor will, fix that right up. And then once it's good enough, send it to the publisher, right? So when we build the workflow, we're basically building a graph. We're saying, here's our start node. This node goes to this node, and this node conditionally goes to either this one or this one. And, here's how you decide, the function used to decide which branch it goes to. And then, here's where it finally ends up. So you could write pretty similar code with the graph frameworks from the other frameworks as well. All right, so let's go and check this out. Let's see, agent framework workflow. Okay. All right, so now we're bringing in the workflow builder class, and let's see, we're using some structured output. It's very common to use structured outputs within workflows as well. That's a nice thing to use. We've got functions here that are deciding, which branch to go to. Like, okay, does it need editing, or is it approved? And then here is our main agent, the writer agent. It says you're an excellent writer. We have the reviewer agent, which says, you're a reviewer, you're going to review it and return back a structured output. And that structured output is, going to have score, feedback, and clarity. So this would be a common approach, is that to have an LLM that has structured output, and to use, one of the fields that comes back to decide what to do next, right? If the confidence score is high enough, we're going to do X. If the confidence score is too low, we're going to do Y, right? That's a really common pattern. Then we have our editor agent that was going to edit, poor, shoddily written things. And then finally the publisher to do formatting. Oh, and then finally the summarizer, which just summarizes everything that happened. All right, and then we build the workflow, and then finally we can run it. So we're going to run it using the Dev UI tool, which is a development tool for working with workflows. And let's see. Oh, did we just upgrade? Okay. All right. I think I just upgraded the agent framework version, and let's see if I can get it. Worked an hour ago. They might have just done a release. Okay. All right. So this is true. We do need to install this extra. I put it at the very top here. So I'm going to install this Dev UI. I didn't have it installed by default in the environment because it does bring in a lot of dependencies. All right. So I'm going to install that. Okay. All right. Let's see if it's going to work here. Okay. So opening up with the Dev UI. Oh, let me get this actually opening here. Okay. All right. So here it is. Let me change that mode. Okay. All right. So this is Dev UI. This is a development tool that we can use in order to test our workflows. It's not a user-facing tool. It's not designed to be a user-facing tool. It's just supposed to be a developer-facing tool. That's why it's called Dev UI, right? So let's just test it out. Be like, okay, write a paragraph about the limitations of the we'll just do the origins of Dia de los Muertos holiday. Okay. All right. So we send this off to the writer first, and it's going really fast. You can kind of see it's popping up at the bottom, and it went all the way through already. And so we can look at each point, right? We can see what the writer said. So the writer wrote this paragraph here. Then we went to the reviewer. The reviewer returned back accuracy of 90, clarity of 85, completeness of 80. It gave some feedback. And that was good enough to go off to the publisher. Because let's look at what our conditions were. Our conditions were that, okay, review score greater than 80, right? So that got a review score greater than 80. So it went to the publisher, who just added some formatting, and then the summarizer here, right? Let's see if we can get it to have write shoddy paragraph about origins of Halloween. Okay. I don't know if it's going to evaluate it based on whether it's shoddy enough. Oh, good. It went to the editor. It worked. Okay. So it went to the editor. So now we can look and see, okay, this time the reviewer gave it a score of 78, which meant it was under that bar of 80. So that went to the editor, and the editor made some edits and then sent it to the publisher. In this case, it didn't go, this workflow doesn't go back to the reviewer. You could do that as well. But in this case, we trust the editor and we send it to the publisher. I see a comment that it's similar to N8N, which is like a workflow builder. So I think it looks similar to N8N. But one thing to keep in mind is that this is just a visualization. I'm not doing any sort of editing here, right? So I'm not like editing these things and having it turn into code. I am just running it this way and then seeing the results, right? So it is a visualization tool for seeing what is happening, which is really nice. It's very nice and visual and helpful to see all the, all the things, the events that go off here. But it is not a like low code workflow building tool because I can't actually do any sort of editing of this actual UI here. So I think it's actually more similar to LangGraph Studio, right? I've got LangGraph Studio open here. And like, once again, this visualizes the flow of a graph, but we can't actually edit the graph, right? All right. So that gives you the idea of a workflow and how you might work with them. Now let's talk a bit about human in the loop, right? If you are building workflows with agents, you very often want to involve humans in the loop at some point, especially if your agents are taking any sort of like action in a system, right? If they're changing something about the system, right? If they're writing an email, if they're making a comment, right? Like if they're taking actual actions on your behalf, then you often do want to add a human in the loop because you really want to trust that the results are high quality, right? Because, LLMs are impressive with how much they can achieve. But remember, they're non-deterministic, they can hallucinate, they've got a lot of risk to them. So I really recommend finding ways to bring humans into the loop in your agentic workflows so that you have a lot of confidence in, in what the agent has suggested it should write and thumbs up or thumbs downing it. So I have a agent that I built in Langchain with LangGraph where I'm the human in the loop. And so I'll demonstrate that one, right? So this is a agent that helps me triage the issues in our most popular open source samples, which they've got a lot of stale issues and a lot of them can be closed. So what this workflow does is that first it looks for the oldest stale issue. Then it researches the issue using a Langchain Langchain V1 agent. And so that researcher can look at lots of things. It can search issues, PRs, search the repo, anything it needs to look at to figure out whether the issue is still a valid issue. Then another LLM will decide what the correct action should be based off the results of the research. So it'll say, oh, okay, I think we should close the issue, open the issue, we should assign the issue, right? It can propose any of those. And at that point, we send the proposal to a human, that's me, and then I can review it and to say good or bad, or I can actually edit it and say like, okay, I like this part of your proposal, but not this part. And then we make the change happen. So I've got this running. I have this running locally here. This is using my my GitHub API token since it has to do things on my behalf. So let me open up a new window so I can show you it working. Let me see. How would we open a new one? Here, I'll just restart. I'm going to restart this agent here. Okay. There it is. All right. So that opens up this Langsmith Studio UI, and this looks really similar to Deb UI. There's a lot of similarity here. It's rendering my graph. This is my LangGraph graph. It's a very simple graph. It's very linear. The important thing is that at a certain point here, there is a human interrupt where the graph pauses and waits for the human to make a decision, right? So I'm just going to tell it to go and research a new issue. So I just click submit. So the first thing it does is select the issue. That's just an API call. That's very fast. So it's got the issue, and this is the issue that it's selected from the repo. And then it starts researching the issue. And so the research step is it takes a fair amount of time because it can do quite a few calls. It's got a lot of tools it can use here. I'll show you the tools it can use. So here it can search issues, code, pull requests. It can get a pull request. It can get an issue. It can fetch a whole file from the repo, and it can list all the files from the repo. So these I'm using the GitHub API in order to define all these tools, and I'm giving all these tools to the agent that it can use in order to research this original issue here, right? And this is the actual issue that it is researching and deciding what to do about. So in this Langsmith view here, I can watch all the calls go out to the LM as they're going out, just to get a feel for what it's doing, right? So it's calling search code, it's calling search code, it's calling fetch file, it's calling search code. And it's going to make quite a few calls. And I remember one of the questions we had yesterday was about, like how to do rate limiting on your tool calling. And that was something that I did have to grapple with for this agent, because sometimes it just wants to research forever. And I'm like, hey, listen, like you've gone too far. Let's stop researching. So let me show you how I did that. So I wrote this middleware. This is a concept from Langchain, is that you can have add a middleware to your agents. So this is my tool call limit middleware. It checks to see the current number of tool calls, and it checks to see if they're over a limit that I've configured, and then actually adds a message that says, hey, no more tool calls can be made. Now it's time to summarize what you've learned, following the format. And so I remove the tools. I say, hey, you got no more tools and it's time to summarize, right? So this is how I manage to, basically limit this agent and cut it off after a certain amount of time, is by putting in this middleware that detects the number of tools and decides when we've gone over the limit, right? Here you can actually see all the tools, lots of tools. They all use the GitHub API there. And let me show you how I configured it, right? So this is where I configured the agent. So we have the prompt, the model, the tools, and then we have the middleware, which limits the number of tools. All right, so we can check back and see how it's going. So it's done its research, and at the end, it makes a proposal. And that proposal is using structured outputs. And that raises a human interrupt. That's what they call it in LangGraph. Let me see if I can find human interrupt, right? So we've raised a human interrupt, which pauses the graph at that point. And so then that gets sent to this agent inbox that I'm running here. So this agent inbox, the idea of this agent inbox, this is from Langchain. The idea here is to show all the paused workflows, like the paused agents that need interaction from a human, right? So I can look at this one from earlier today and, see what it says. So it says, okay, yes, we should close the issue. Let's add this label. Let's remove the stale label. We're not going to assign it to Copilot. Here is the suggested comment. This is the one that I often will edit. And I'm just going to edit it like this. Okay. So then what I can do is submit. And then it'll actually go out and close the issue. I didn't know. Okay, I'll open the issue for next time so you can actually see it, close it. All right. So this is the one it just looked at. So this is the actual issue. And it says we should not close this issue. And it says that we should have an explicit note about the reopen in container issue. I think I'm gonna close it. I think we can close it. It's I'm going to close as this hasn't come up recently, and it's unclear that this is needed. Okay, so I'm going to say close it, close it, close it, and I'm not going to assign it to Copilot. But we could have assigned it to Copilot too. But I'm going to close it, and then there you go. There's the comment that went through, right? So that's the idea, is that, this agent, it just posted on my behalf, but, I approved what it said. I was okay with what it said. And, I let it through. Right. So this is one way that you can handle having a human in the loop, is to actually have a user interface that, renders the pending paused actions from an agent and lets humans decide what they're going to do with that. Right. Now, if you're going to do that, you need some sort of way to persist the agent state, right? So for Langchain, we're persisting thanks to Langsmith. If you're using agent framework, you would need to persist with some other sort of mechanism, right? And so you have to kind of think through that. So hopefully we'll continue coming up with more examples of different ways that you can involve humans and different interfaces for what that could look like, right? Because it depends on whether the human is there while it's happening, or if you've got like a background process that's just processing these, and the human at some later point wants to look through and decide what to do. All right, so let's look at a couple other features that are commonly associated with agents: planning and memory. So first, let's talk about planning. A lot of times people think of agents specifically in terms of planning. Now, you could argue that the agents we saw so far were basically doing planning, right? Because by virtue, if you give an agent a goal and you give it a bunch of tools, the LLM itself is basically doing some sort of planning, right? Because it realizes like, oh, I need to call this tool first and this tool first, it's next, right? But it's not doing explicit planning. So some people will actually add explicit planning steps to the agent and planning, and actually give the agent planning tools to really force it to be more structured about the approach it's taking for something. So this can be particularly helpful if the tasks are really long tasks, right? Because then you're like, you're making sure it's going to be thorough with accomplishing that task. And there's two general ways of doing planning. One would be a prompt-based planning, where at the beginning you just have an explicit first step that says, okay, you're going to make a plan. Here's your tools. Okay, and really tell me exactly what you think the best plan is, right? And then the LLM can always refer back to that plan that it wrote itself. The other approach would be to actually give it a tool, like a to-dos tool that says like, okay, you can just update your to-dos, right? Come up with all your to-dos and then update them as you go along. And each to-do would have, the content and whether, its status, like whether it's done or in progress or still pending, right? And an example of this is GitHub Copilot agent mode in VS Code does have a optional to-dos tool that you can use, right? And you can see it here under the GitHub Copilot tools list. And when you do that, then GitHub Copilot will actually show you a bunch of to-dos when it's working on a task. And this can be particularly helpful for really long tasks, like a big refactor of an application, right? So what does this look like in Python? So as an example, I'm demonstrating here the Agentic 1 orchestrator from Agent Framework. This is a orchestration agent that has a task ledger built in, and where it's constantly like checking that task ledger, deciding whether the tasks are complete, and deciding what tasks to do next. This came from AutoGen. So if you knew AutoGen, you might have seen Agentic 1 in AutoGen, and it came from Microsoft research about Agentic 1. So you can read the research about it. But that's generally the idea, is that it's going to make up this ledger and decide what to do next. So let's just go ahead and run that. So that is Agentic Framework, Agentic 1. Actually, I'm going to run it locally just because it'll be a little faster to run with my Azure model here. Let me give us some space here. Agentic 1, let's start it running. So this one is going to do plan a half-day trip to Costa Rica. And it's got a agent that like has local tips. It has a language agent that knows how to like, speak the language of the country. And then it has a travel summary agent. So what you can see is that as it goes along, the first thing it does is it says, okay, we have this team of agents that can help us. We have these facts, and now you need to make the plan. So this is the plan it comes up with. It says, okay, we're going to consult the local agent. We're going to use the local agent. We're going to make this itinerary. We're going to send it to the travel summary agent, and then maybe optionally engage the language agent to get some Spanish phrases, right? So this is the plan it comes up with based off the agents that we've passed to it. So then it starts working with the agents, right? So the orchestrator says, okay, my first agent is the local agent. So I'm going to give it this specific instruction, right? So this is like a supervisor agent that is very specifically sending tasks to these sub agents, right? So the local agent says, oh, okay, sure, orchestrator, here's the information you want. And then the orchestrator says, great, we're ready for the next step, and gives a specific instruction to the travel summary agent. And then we got a travel plan here, right? And it came up with a pretty, this time it was pretty fast. Sometimes it's going to come up with a longer plan. So that's one way, that you can implement planning in your agents. Now I want to talk briefly about memory. And when we talk about memory, people mean so many things. So I like the breakdown they have of this in the Langchain docs, and I link to it here if you want to read how they talk about it. So they contrast short-term memory to long-term memory. So short-term memory, you can think of it as being the conversation itself, right? Anything that happens in the conversations, messages, tool calls, any sort of state you want to update in the conversation. And that's something you can basically like pass through an agent, right? Like by default, the agent frameworks are going to remember messages and tool calls. But if you wanted to add anything additionally, usually there's some way to, weave something through a conversation. Now, the interesting thing about short-term memory is that if a conversation gets quite long, then that can overwhelm the context window of an LLM. And then you may need to truncate the messages or summarize. The more common technique these days is summarization to make sure you don't lose anything like really, really important. I used to do truncation, but then realized I was probably, missing some things that important at the beginning or end. So most common technique is to detect, basically add a middleware that says, oh, we're over the context window. Let's summarize and just insert the summary into the message thread. And if you're using Langchain V1, there's actually a summarization middleware that will do that for you, right? So with short-term memory, typically you can just keep that entirely in memory. You only need to persist it if you have a UI that lets people view their previous conversations and then pick up with that previous conversation. So ChatGPT does actually let you pick up on a previous conversation. So they do need to actually persist the conversations to a database so that they can restore it. So you need to think about whether you need to persist conversations like chat history to a database or not, and how that's going to work. The other kind of memory is this like long-term memory where you're like letting agents learn little like nuggets of information about you and then storing that in a memory store, usually tied to a user. And so that you definitely need a persistent database, and you need some way of realizing that there's something important that should be saved. And that's quite tricky to do well. ChatGPT tries to do it and lets you even inspect the memory that it has. And it's pretty interesting to see what it stores there and in what it thinks it's memory. But basically you'd have to make a tool that's like a save memory tool that the agent could use when it decides that there's something, relevant to save. So that's hard to do well. And, there's libraries like Mem0 that, only do that. So I don't have examples of either of those yet. To be honest, I haven't worked a lot with long-term memory, but that's just to give you an idea of what you want to think about in terms of memory. All right, we have 1 minute left, and we unfortunately cannot go over today, both because there's another live stream right after this one, and also I am going to San Francisco right after this for the PyTorch conference, which will bring together lots of Python and AI people. So that'll be exciting. We're sponsoring that. So I tried to answer some of the questions as we went along. I know I didn't get to all of them. If you have additional questions, what I recommend is actually posting it in the resources thread that we can link to here. This is the discussion thread that has, has the top, it has all the slides and recordings and code samples. But then you can also ask questions here. So if there's a question I didn't get to that you're wondering about, post it here and I will, I'll get an email in my inbox. And it's the inbox I actually watch. So it's a good place to post. We do have office hours on Tuesdays in Discord. So we already had one yesterday. We'll keep having them after the series ends. So we will have another office hours next Tuesday. So keep coming to those office hours on Tuesdays and we can keep talking about everything going on in the space. So that's another place to bring questions. And then of course we have our final session tomorrow about MCP. So we hope that you'll all join us in order to dive into MCP. So there we're going to see how to write our own MCP servers and also how to point agents like the ones we built today at MCP servers so that they can consume tools from MCP servers. So lots of machine ways that we can use MCP and hopefully you can join us for that. All right. Thank you, everyone. I do need to go now. Thank you so much for all the great comments in the chat. Great questions. As always, we'll see you next time. Bye.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.